Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now let's get started on our set of questions for this session. Okay, so question 1 asks, which has the larger second ionization energy, lithium or beryllium? And explain why. Okay, so let's recall what ionization energy means. This is the minimum amount of energy that is required to remove the most loosely bound electron of an atom or molecule. So first, let's look at lithium and beryllium's electron configuration. So in the case of just a neutral lithium atom, it has an electron configuration of 1s2, 2s1. So this shows that it has only 3 electrons in the atom. The first ionization energy is when you remove the first valence electron. So this gives us lithium plus once an electron is removed, and it now has a new electron configuration of just 1s2. So the question is asking for the larger second ionization energy. So as you can guess, when you have a second ionization energy, this is the removal of a second electron. So if we were to remove a second electron, it becomes lithium 2+, and its new electron configuration is 1s1. So now let's do the same thing for beryllium. So beryllium has an extra electron. So its electron configuration is 1s2, 2s2. If we were to remove one electron, this is called the first ionization energy. We get a new electron configuration of 1s2, 2s1. And then lastly, if we were to remove a second electron, this is the second ionization energy. We now have an electron configuration of 1s2. Yeah, and that's it. So if we look at both our lithium plus ion, and if we look at our beryllium plus, you'll notice that our lithium plus is already in the inner valence shell, and it's very close to the nucleus. So let me just write that down. Lithium plus has its electrons closer to the nucleus. So the closer you are to the nucleus, the harder it is to remove an electron because it is more positively charged in the nucleus. So therefore, it will be harder to remove an electron I'll put to remove an additional electron. So because it's harder to remove an additional electron, that means it will require more energy. So therefore, we can say that lithium has a larger second ionization energy. Okay, so let's look at beryllium plus. If we were to remove one electron, its electron configuration is still 1s2, 2s1. So it's still pretty easy to remove another electron, so that means it requires less energy. So the beryllium will have a lower second ionization energy compared to the lithium. So the junior tutor said, to answer this question, let's write the electron configuration of lithium and beryllium first. Lithium is 1s2, 2s1, and beryllium is 1s2, 2s2. The ionization energy of an atom or ion is the minimum energy required to remove an electron from the ground state of the isolated gaseous atom or ion. Second ionization energy, I2, is the energy needed to remove the second electron from a neutral atom. The energy needed to remove an electron from the outermost occupied shell depends on both the effective nuclear charge and the average distance of the electron from the nucleus. The farther electron from the nucleus, to less energy it would require to be removed. So the farther the electron is from the nucleus, it requires less energy to be removed. In beryllium, the first and second electron is on the second energy level, while on lithium, the first electron is on the second energy level, and the second electron is on the first energy level. The first energy level is closer to the nucleus, thus lithium would have a larger second ionization energy than beryllium. Yep, so this solution is correct.